Hello, everyone. Good afternoon, ladies and gentlemen. My name is Ēriks Diļevs. I'm a technical director of Rail of Latvia, and I'm more than welcome all of you to join for second Rail Academy lecture. So this is just to give you more insight on our railway project of the century in Baltics, I would say, to give you more insight on different railway solutions, technical structures, environmental solutions, how we're going to treat environment. Yes, just to give you deeper insight on all of those questions, or maybe that you are keen on to know about current, establishment and development of the project in all three Baltic states. So in total, we'll have 7 of those lectures. Yesterday, we had the first one. Our presenter was our colleague Ēriks Diļevs, where he basically presented the Riga Central Station. However, today I'm going to give you a brief overview from Estonia towards Lithuania of top 10 infrastructure objects, and of course give you also additional information. So basically at the end of presentation, you are more than welcome to give your questions in the Facebook chat. As much as our time will allow, I'll try to reply to all of you, and enjoy the presentation. Take your comfortable seats, chairs, sofas, wherever you are, and just let's start. So I would like to start just to give you a brief overview of each our country, about the length of our railway alignment, about different passenger stations, what we have, and general parameters of our Rail Baltica railway line. So in Estonia, we have 230 kilometers. We have 3 mainline design sections. Currently, they are all under design stage, approaching already construction procurements for first road crossings, which is basically in Pērnu Rapula here in the middle. We have 2 passenger stations, 1 multimodal terminal in Muuga. Then if we go towards Latvia, we have 4 mainline design sections. Also all are under design stage. The north is under value engineering, basically where we go on site, carry out site investigations, and study different structure solutions, or yes, based on ground investigation models. And of course, we have also passenger stations, which is Riga Central and Riga Airport station. We have also 1 multimodal terminal, which is located in Salaspils here. In Lithuania, we have also 4 mainline design sections, 3 passenger stations, 1 multimodal terminal. However, currently we have under design stage 2 of those sections, which is Kaunas to Ramigala and Ramigala towards Lithuanian border. The rest of the sections, Kaunas Vilnius and Kaunas Polish border, is under, let's say, plan to be procured soon. So of course we are going to also link Poland with this our high-speed line. And here you can see also design parameters. Some of you maybe already know them, but those who don't, just give you a brief reminder. So yeah, we have 249 kilometers per hour for passenger trains and 120 for freight. It's European standard gauge 4035, and it's of course double electrified track. Then if you jump to structures and how we split it in all 3 countries. So as you see in Latvia, as the main line is the longest one, so we have also the majority of structures here. In Estonia, it's a bit less, 121, and Lithuania, 107. And we have also different, I would say, separate structures, which are not so, I would say, everyday designs in Baltic states. Here are only listed the several ones, however, we have more of them. Some of those I will present in the next slides, because I would say those are definitely one of the top 10 construction objects in a Rail Baltica line. But of course, we have also many others, such as passenger stations and so on. Here you can see the breakdown of structures as per each design section, as I already mentioned before. So in Estonia, we have 3, and here you can see the number of structures which we have in each of those design sections. I think the number 1 is mainline through Riga, design section 1, where we have 67 of those. And in total in Latvia, we have 204. Of course, as I mentioned, some of those designs are still in value engineering stage, so the number might change, but of course not so significantly, but maybe few of them will be less or more. So let's jump to the most interesting part. I would just give you an overview of each country. So I would say I have listed some of the most iconic structures, which is worth to think about for future, and also which I would like to present you today. So why I chose Ulam is the passenger terminal in Estonia, because basically here will be the chain H00, where the Rail Baltica corridor actually starts. And this Ulam is it's something like similar to, I would say, Riga Central Station, also very crucial transport hub in Tallinn city. So here you can see we are adjusting 2 additional tracks of our Rail Baltica line, and here is existing 50/20 tracks, which is currently, serving railway transportation for Tallinn city and for whole Estonia. And this is also will be as a multimodal hub in Tallinn, with linking Tallinn tram line, different bus routes, and other public transport systems. Yes, so it's kind of, I would say, very iconic structure to be designed and constructed. Currently, it's under design stage. First stage of construction works is about to start this year. Consultant is very famous Zaha Hadid Architects. I think you have heard this name. They have designed many iconic buildings throughout over the world, and they have also a local subcontractor Esplan. The contract value is 2.6 million euros. So yes, this is currently under design, and we have reviewed already first incoming design deliverables. Then if we go further down the line, here are some visualizations from our south section, which is Pärnu towards Estonian Latvian border. Here I have listed 2 of, how to say, different station examples. This is regional station Kilksema, where you can see the idea how Rail Baltica line will cross different villages, districts, and where we are providing also like regional stations. Those, of course, are not so big as you see on the right side. I will tell about this a bit later. But here, what I want to point out that we are providing full, also some kind of multimodality to this even small station. There is access road, there is road overpass, there is parking lot. So we have, with this project, we also want to ensure that there is like proper facilities provided to the local inhabitants, that they can park their car, jump into the train, and go wherever they want. And this is like, we need to provide full service for all the passengers and inhabitants where we're crossing these regional districts, basically. And on the right side, you can see Pärnu passenger terminal, which is, of course, smaller than Ulamist, but also showing you an example how it's going to look, how we're going to provide this also multimodality in Pärnu, how we're linking different public transportation systems. And here on the left side, you see Pärnu River, which is, yes, just lying next to this station. Then I touched already Pärnu River. So one of the biggest structures in Estonia is Pärnu River Bridge. Some of you maybe think, okay, 320 meters is not nothing major, but this structure is also a bit unique with that Pärnu River has a bit, kind of challenges with highest water level, and there are different also ice flowing throughout spring time, and this is one of the challenges also what we needed to face here, because as you see, there are local roads below the bridge deck, and the water level is changing quite significantly. So we're also carrying out different hydrological studies and investigations how to tackle it, how to properly calculate the highest water level. So by ensuring that the local roads are not flooded, and we are, ensuring safety on this. So about the bridge itself, so it's a steel girder with concrete slab deck, 6 spans in total, and the middle span, which is here, is 100 meters long. The bridge deck is 20 meters wide, and the height is 3.0 meters, basically, yes. So let's go to Latvia. As it was already in the Facebook announcement said, yes, you will know something about unique about the first combined structure in Latvia. I would say in whole Rail Baltica railway line, but yeah, it's located in Latvia, and it's crossing Daugava River, hydroelectric power station, this pond, and yeah, it's really something unique. This strategic decision was made last year by our Minister of Transport. Basically, the idea is that it will ensure the full integrity of both infrastructures, road and railway, as the plan is also for road administration to cross in the same proximately the A4 Riga bypass road. So there was this different studies were made and also analysis that actually it will be more feasible to combine these two infrastructures and to cross in one location. So and then we started to investigate and to further down study this proposal. And so currently, yes, we are under design stage with this huge structure. Similar ones maybe you have seen over Øresund Bay, which is owned by Denmark. Then also we have in Khabarovsk something similar where the basically highway is on top of the railway. So if you go into more details about this specific structure, so it's in total length it's almost 1.2 kilometers. We have two high-speed railway lines below and 2+2 road carriageways on top. It's a steel truss girder with 6 spans of 150 meters and 2 spans of 125. This box girder, which you see here, it's 12 meters height. And of course, this is not only the bridge, but it is also the surrounded adjacent interchanges, what we also need to redesign, and actually that is growing quite huge in size. I will explain you later in the slides. Here is basically for you to understand how actually this one pier would look like during construction. So it's something very easy to construct, to provide this whole structure above. You need to also have proper foundation and proper piers. So yeah, this is a typical construction method, how you construct such piers inside the rivers, where you have the sheet piling and then you just pump out the water and do all the concrete pier works and the rest of all necessary works. So yeah, as I mentioned before, so we have total four traffic lanes, and then we have these railway track below the roadway. And we have basically 12 meter from this bottom cord. Cord is basically called these truss girder beams, the top cord and the bottom cord. And basically till the water we have approximately 12 meter height clearance. Then what lies also together with this combined bridge is this A4, A6 interchange, which is A4 is a Riga bypass road, A6 road goes towards east of Latvia. And just to cross this interchange, we need to do major redesign and reconstruction works. So basically, currently this interchange is a small, I would say, called trumpet type interchange, only 2 levels. But with this infrastructure, where railway is also coming in, so this interchange is now as a 3-level grade separated interchange, where A6 highway, which is here, you see this is at grade level. Then Rail Baltica railway is at 2nd level, and A4 highway is at the 3rd level. So yes, of course, we are trying to ensure all the constraints that are there, like existing houses. We are not trying to touch them as much as possible, trying to avoid them. So yeah, this is currently under design, and I'm just looking forward how it's going to turn out, what's going to final solutions going to look like. Then next iconic structure what we have in Latvia is Gauja River Bridge. During preliminary design, it was actually foreseen to be 1.7 kilometers, which will be now actually the longest structure in whole railway line. But currently under the design stage, this consultants has studied it more closely, and we see that it can be shortened up to 1.4 kilometers. What is tricky about Gauja River Bridge that here, as you see on this right side, there is north on the left and here is south. So we have this intercolumns connects us high pressure gas pipelines. And this is also a very challenging location where we have also this 330 kilovolt corridor going towards Estonia, which is currently under construction. There is also intercolumns high pressure gas cells and all this gas pipeline infrastructure, and then also in between our railway line. So this is a very challenging location. We need to study together with consultants what would be the best location, how to not touch as much as possible all the infrastructure, so we're not affecting it. And of course we're trying to avoid as much as possible, but anyhow, yeah, here is an example how the side pier of the river would look like. So we have central span of Gauja River, which is here is 110 meters. And of course, the central span height also is quite significant, is 7.0 meters. and the central pier height is 40.5. So this is about Gauja River. Then we jump to the next very complicated area. This is the main line of Riga. Those who lives in Riga knows where is Torņakalns and actually where is our central station. So this is where also the first railway tunnel in whole Rail Baltica line will be located. I would say this is the most complicated section in all railway line, because our railway corridor is going next to our existing 1520 railway tracks. And those are tracks basically that are going to south of Latvia and to the west of Latvia. And there is one specific location where Rail Baltica railway is crossing the junction of those two lines, where they are, one line is diverting towards west, another is diverting towards south of Latvia. And also our railway line is crossing those two lines. And of course, according to our design guidelines, there is no at-grade crossings allowed, only two-level. So that's why the only option, I would say the best one, which already has been studied and approved, is this railway tunnel. Tunnel itself is not so complicated as you would see, for example, for different railway tunnels in whole world. You know, from tunnel, it's not so something like huge, but it's complicated because of the different railway operations, what we need to also provide during the tunnel construction stage. So initially, tunnel was planned to be 2.5 kilometers, which will basically end after this street. However, consultants during design has, studied different risks, such as this river crossing and also the whole capex of the tunnel. So it was actually studied that it's more feasible to shorten it, because the critical part is basically here where we need to cross this two existing railway lines. So currently total tunnel length is 1.3 kilometers. However, the tunnel underground is here in this red section, which is 350 meters. These green lines are basically exit entrance ramps to the tunnel. So here is a typical cross-section of this tunnel, how it's going to look like. So we have two railway lines in it. The construction method is cut and cover, which I'll explain you in the next slides, what is cut and cover for those who don't know. And the depths of these tunnel diaphragm walls, which are here on the left and right side, the depth is up to 20 meters. Precisely, I would say it was 17 point something, but well, the depths might vary. And the tunnel width is 14.1 meter. So then more details on this cut and cover and top-down construction. So basically, as I mentioned, in the world, another part of the world, this is not something very complicated, to construct. We have seen different examples how it's being done in different countries. So what is top-down construction? You start with constructing these diaphragm walls on the left and right side. Basically, you drill like huge boreholes filled with the reinforcement and concrete. Then you put the top slab. And then you start to excavate from one and other end, this material inside. So then gradually you go just line by line down towards the bottom. Once you have, excavated full amount of these mineral materials. And then you basically put back the top of mineral materials, and here you go, your tunnel basically is constructed. So this is one of the best solutions how to construct such as cut and cover tunnels, also to have a less impact to railway operations and to provide best possible solutions for this. And of course, with this solution also we need just one common pumping station at the lowest part of this tunnel. So in real life, how does it look? Here is just an example. How does it look, which I showed you just before with this, how you excavate the material below. You see those are these diaphragm walls. And here is an example, the height of, for example, the height of reinforcement, which you need to fill in this concrete diaphragm walls. So you just go step by step, construct left-hand side wall, and then go further down. Here is an example of one section of this tunnel where we are going close to the existing buildings. Of course, our consultants are also keen to do as much as possible to not damage any surrounding infrastructure, and of course this is our aim. So there are also different construction technologies how we can provide, ensuring the best possible solutions, not to damage, not to affect any kind of houses or other infrastructure around. So by doing this, basically, once we, before even constructing these diaphragm walls, we construct here a sheet pile, and we put this anchorage so that it does not affect the foundation and of the soil conditions of this adjacent buildings. And then further down we construct with the same technology. So yeah, anyhow, consultants are studying this further down, doing more details, and of course we will provide you more information as the design goes on. Then one thing what I want to also mention, which is a bit iconic here in Baltic States, what we have currently designing, these are these combined road animal crossings. This is something has not currently been designed in Baltics at all. However, it's a normal practice in other European countries where, for example, some kind of greenfield objects are crossing forest areas, and we are also our project aim is just to save as much as environment and not to affect at all. So we are speaking about animals, about how they're going to cross our railway. So we have also, of course, pure aqueducts, which is without any kind of additional, let's say, gravel road stretch, I believe, in between. However, for those areas where, for example, traffic intensity is very, very low, like, I don't know, a couple of cars per day, and also next to that is aqueduct, then there is solution to combine it. It's nothing that animals, for example, would afraid to cross it. It's just to provide them the best environment on the left and the right side, where they have stretch of let's say, how to say, green space where they can comfortable cross the railway. And the typical lengths of these structures are 66 meters. The width of the structure is 22. So here 7.5 is gravel road, and then on each side we have 15 meters of these total 15 meters of animal walkways. Here you can see how does it look in real life, how other countries have implemented it. So here you can see this is, for example, a stretch of the gravel road, and here is enough space of greenery where animals just easily can cross the transport corridor. So this is something we are aiming for in those places where we need to combine those aqueducts and some kind of minor road crossings, forest roads. Of course, we will, as I mentioned before, we will also have proper aqueducts dedicated only for animals. Then let's jump to Lithuania. Of course, everybody knows this Neris bridge, those who are Lithuanians. Those who are not, I would give you more details about this iconic structure in Lithuania. Indeed, this is the longest structure in whole railway line, Rail Baltica. It's 1.5 kilometers long and with a central span stretching of 150 meters. Why the central span is so long and there are no piers in the river? Because this is a Natura 2000 territory, and due to different constraints of this Natura territory, we are not allowed to put any piers in the river. Of course, we are also thinking about, how to say, different environmental constraints and so on, and this is not our objection. So we always are looking forward towards, collaboration with different institutions and affected parties and authorities. So yeah, that's why the central span is 150 meters long, and we don't have any kind of piers in the river. Piers are only on the side banks of the river. And the number of spans are 29 in total. The highest bridge pier is 37 meters, which is quite tall, I would say. And as the structure is, how to say, so huge, then also number of and the lengths of total board piles are quite significant. So we have almost 7.7 kilometers lengths of 1.5 diameter board piles and 2.2 kilometers of 1.8 diameter board piles. I mean, it doesn't mean that those piles are such deep, it's just when you count all of them together. But the number itself is quite significant to, for typical structure in Baltic States. And yeah, speaking about the bridge, it's pre-stressed reinforced concrete box girder, which also complies with our design guidelines, of course. And here in this picture, you can see this A-shaped type pier. Then some of you maybe might ask why it looks like and why it's there. Basically, as you know, this is a high-speed line. It's a railway. It's not a road, bridge. So we are trying to how to say, ensure as less as possible expansion joints. So this is a rigid structure where basically the majority of all the braking forces should basically take this load, and that's why the designers introduced this A-shaped type rigid structure. Basically, from bridge design perspective, the worst case is that two fully loaded freight trains brakes at the same location. So this is the worst case scenario where you need to take into account when you're designing your structure. So and here in the bottom picture, you see this, where it's located. It's almost approximately in the middle of the structure. Then how does it look from the design perspective? Of course, you heard that Rail Baltica is also, providing BIM solutions, and we are asking from our consultants to provide all the design solutions in BIM environment. I will also explain a bit later how does it look. And here in this slide, you can also see how does it actually, the BIM model look like. So before you saw the visualization, and here actually it's a direct extraction from designs from the BIM model, where you can see, so here we have a pile cap, here we have board piles, here is a pier, and here's the bridge deck. And here, for example, you can see some kind of utility crossings, different other infrastructure, what is there in this model. So basically, BIM model includes all the necessary information what you need to find out to be able to construct, to give this BIM model to the constructor, so he can already provide the right estimate, with less contingency as possible. So, and also by clicking on each of these element, you can get information about the concrete class, about the quantities, and so on. So this is one of our aim also of this project, and also to basically to develop this BIM technology in Baltics in general. As you know, in other European countries, it's already developing, and it's a normal practice to provide design in BIM environment. Then additional, I would say, iconic structure, which is in Rail Baltica railway line, is this Musa river bridge. Why I would say it's iconic? Because it's right on the border of Latvia and Lithuania. It's in this border is in the middle of this Musa river, and our railway line is also crossing this Musa river. So this is a bit also challenging because we have two different country legislations. We need to combine all those legislations in one structure. And in the same, we need to provide also, how to say, proper design from both parties. As you can here see, for example, the terrain is also a bit different on each side of let's say, border. Here is Lithuania, this is Latvia. And this is currently also under, I would say, approaching towards master design stage. We are just now in discussions about the vertical parameters of this structure, but more or less it's already set. However, this is the type of structure, how it's going to look like. So it's basically post-tension concrete box girder. The total length is almost 160 meters, and the central span width is 65. And also it's pretty high. The central span height is 5.0 meters and central pier is 12 meters. Here, this is a current situation. This is Musa River. How does it look like? And here basically how it's going to cross it. Here it's an example where you can see how in such solutions where we cannot put some kind of scaffolding or formwork inside the river, and also it's possible to construct from each side of the river bank by using this cantilever method. So basically, we are constructing bridge from the bridge itself. We are just putting formwork, pouring concrete, and then just approaching left side to right side, and once just we complete the middle, and then the bridge is constructed. So this is one of the construction methodologies what we intend to use when constructing such kind of structures. And last but not least, yes, as I mentioned, BIM environment in Rail Baltic project. As you can see in these videos, we can zoom in, we can click each element. Each element shows the parameters, the concrete class, the quantity. So as I mentioned before, our intention is to give as much as detail to the constructor with these BIM models, so we can estimate and get all the information what is in the design, and yes, how he needs to provide the price estimation for these works. So Yes, this is, I would say, small insight of our everyday work in Rail Baltica design and all this mega project, how we are moving on. I hope you enjoy, and thank you very much for attention. And yes, if you have any questions, please ask. I would be more than welcome to reply. Thank you. Okay, so yes, questions are coming in. So first question, I'm wondering if there are enough construction materials in the Baltics to build all structures for Rail Baltica railway line. Yes, thank you for the question, very good one. Yes, there are enough materials. In general, of course, we have carried out mineral material studies in 2 stages, where we actually investigated about the possibility to use local materials as much as possible. Of course, there are some of the materials that need to be imported, such as ballast. That's no, how to say, secrets of it, which will basically will be imported from those countries that has a lot of granite and igneous rock. Yes, but basically the main mineral materials where we can construct embankment, we'll try to use locally produced materials. So yes, I would say yes, there are. So question number 2, how people will be able to cross the Rail Baltica railway line in urban and rural areas? Also very good question. Yes, of course we have thought about it, and these solutions are being implemented. People will be able to cross railway line. We have provided pedestrian overpasses, also with possibility for disabled people to cross the railway line. There will be also, as I showed before, these road crossings with sidewalks. With sufficient spacing and also that can lie with the surrounding infrastructure. So we have ensured full integrity of also people to be able to cross the railway line. So as I see, no more questions are coming in. No more questions? Okay, then if no more questions, then I would say thank you for your attention. I hope you enjoyed it. And next week we will have the next lectures, and you can find out in our webpage, also here in Facebook. Yeah, thank you very much. I hope you enjoy. I hope you had more insight on different infrastructure objects in our railway line. And yes, thank you very much and take care.